All right, today, lesson pre-02A, more review of the important things from 7th grade. Our focus today is on expressions and properties. So you should have your packet open to this lesson. If you're not there, pause and make sure you get to that point. Our focus today, as I talked about in the last lesson, the daily learning target is essentially what our focus is for the day. So today, you will be able to simplify algebraic expressions. We'll also go through some terminology there. If we were to shoulder partner, you'd be able to describe which properties were used to simplify an expression. And one of the many reasons, one of our main focuses in 8th grade is solving multi-step linear equations. So this is important for that as well as other things. So a little bit of background knowledge. Background knowledge is essentially some things from the past that are very important. From at least 6th grade and 7th grade, the commutative property is a very important property in math. It allows us to really do some mental math, and what it really states is that order in specific certain math problems doesn't matter. In other words, you can flip-flop numbers around addition problems, or you can also flip-flop numbers around multiplication. It doesn't really change what's happening. The word commute, part of the word commutative, means to travel or change, and it is often used in association with a location. For example, we say some people commute to work. And so the commutative property of addition, the generic form, looks like that. And I know at this point we should be filling in some things in our notes. And then some examples with numbers. 5 plus 7 is equal to 7 plus 5. That's kind of common sense. And this property some of you have been doing for years and you didn't even really know it. But it is the commutative property that allows us to flip-flop numbers around addition because it doesn't matter. You're going to get the same answer. 10 plus negative 3, the answer to that is 7. That's the same answer that you get if you flip-flop the negative 3 and the 10. Negative 3 plus 10 is also 7. So you can see that it clearly doesn't matter. Here's another one where we have 3 numbers, but we're essentially flip-flopping the 7 and the 2, and you can see you're still going to get the same answer. You've got 17 for the answer on the left and also 17 for the answer on the right, so it doesn't really matter. The commutative property also works for multiplication. There is the generic form right there, but if we use numbers, clearly 4 times 8 is equal to 8 times 4. And once again, you should be continuing to add the examples to your notes. Make sure that you are doing that. Another example might be 12 times 3 is equal to 3 times 12. Or maybe negative 1/2 times 8 times negative 7. That is equivalent to 8 times negative 1/2 times negative 7. And in that third example, right here is where we are doing the flip-flopping. But it wouldn't matter. We're going to get the same answer. In fact, the answer on the left would be 28, and the answer on the right is also 28. And as we're going through these, at any point, if you're watching this screencast, that you need to slow down, just press pause, then press play when you are caught up. All right. Another important property from earlier grades, definitely 7th, definitely 6th, probably earlier than that, is the associative property. And the associative property tells us that when we regroup numbers, it's okay. You can regroup numbers together using parentheses. And the word associate means partner or connect. Most often we use the word to describe groups. For example, if a person goes to UStack Middle School and not Savage Middle School, we would say that person is associated with UStack Middle School. The associative property of addition, the generic form looks like this. With numbers, it would look like that. That would be an example. So notice that on the left, we're grouping the 4 and the 2 together. But in the second expression, we're going to instead group the 2 and the 9 together. Notice in both sides, though, we have the 4 and the 2 and the 9. And all this is telling us is that if we group around different numbers, if all we have is addition in the problem, it's not really going to matter. We're going to get the same answer. On the left side, we would get 15, and on the right-hand side, we would get also 15. And even if we use negative numbers and 4 numbers instead of 3, it's not really going to matter. The left-hand side would be equivalent to the right-hand side. And just like with the commutative property, please make sure that you are adding these to your notes. Pause at any time if this is going too fast. And just like with the commutative property, the associative property works with addition and multiplication. If all we have is addition in a math problem, we can regroup. If all we have is multiplication in a math problem, we can also regroup. And we'll do some examples a little bit later of why that's important or where you could use it. So here are some examples using numbers of the associative property of multiplication. Okay? And then the third background knowledge property coming from earlier grades, the distributive property is used in the 7th grade and in the 6th grade and in the 5th grade. And even if you don't remember it, we're going to go through it very quickly. So the generic form of the distributive property would look like that. If you have A times the quantity of B plus C, that would mean that we could multiply the B by the A and the C also by the A. And it also works for a subtraction inside of the parentheses. So if we just use numbers, it would look something like this. So we're going to multiply that outside 3 by the 4 and the 5. Now, if we just use the order of operations, clearly we wouldn't need the distributive property because all we have is numbers here. So typically, if we were doing this problem, we would use the order of operations. So we would have 3 times 9 because 4 plus 5 is 9, and then 3 times 9 is 27. But we could also use the distributive property instead, as I was stating earlier. So 3 times 4 plus 3 times 5, so we would have 12 plus 15, and that equals 27. Now, we wouldn't really need the distributive property if all we had are numbers, because this problem is probably easier to use the order of operations. So when do we really need the distributive property? Well, we need it if we have variables involved. So something like 3 times the quantity of x plus 2. We definitely need the distributive property here to simplify that expression. So, just like in the previous problem, we're going to multiply that outside 3 by everything on the inside of the parentheses. So we're going to multiply the 3 times the x and also the 3 times the 2. We're going to add those two things together because of the fact that we have addition here. And then simplify wherever we can. We can simplify the 3 times the 2. And so that simplifies to 3x plus 6. So in other words, 3 times the quantity of x plus 2 is equivalent to 3x plus 6. Now this part right here, this is usually the part that you are doing in your head. And when I taught this in the 7th grade, that's exactly what I said. The step in the middle, that's the part that we're usually doing in our head. And once again, we should be filling in blank areas in our notes for everything. Pause at any time if you need to. All right, so something now from 7th grade, parts of algebraic expressions. And this is just so if I throw out these terms in specific problems, you know what I'm talking about. So a term in an algebraic expression is part of an algebraic expression, either a number or the product of a number and variables, and terms are separated by addition or subtraction symbols. That's key right there. So if I asked you how many terms are in this expression, well, there are 6 terms in this expression because that's a term, that's a term, that's a term, that's a term, this is a term, and that is a term. Notice that they are separated by addition or subtraction symbols. That's what makes 6 terms in this particular algebraic expression. So once again, there are 6 terms, and they are separated by addition or subtraction. Some other important parts are sometimes you're asked just for the actual terms. So positive 7x is a term, positive 3y is a term, negative 4abc, and we always take the sign in front, is a term, positive 6m to the second power is a term, positive k is a term, and positive 2 is a term. So some other important words here, one of them would be a coefficient. A coefficient is a number that is multiplied by a variable. So once again, a coefficient is a number that is multiplied by a variable. So the first thing that you have to have in terms of what a coefficient is it's only involves variables. So it says it's a number that is multiplied by a variable. So one way to think about it would be if you have a number in front of a variable, that is a coefficient. And you always, like with the terms, need to take the sign in front. So I just circled one of the coefficients, positive 7. A positive 3 is another coefficient. Negative 4, not positive 4, but negative 4 is another coefficient. Positive 6 is another coefficient. And then while I know there isn't a number in front of the k, there really is. We just don't typically write it. We can, but we don't have to. So there really is a positive 1 in front of that k. So that also means that there is a coefficient of positive 1. So positive 7, positive 3, negative 4, positive 6, and positive 1. Those are all coefficients. And then we have this other number that does not have a variable next to it. In other words, it's not multiplied by a variable. That's not a coefficient, but there is a name for it, and that is a constant. So a constant is a number that has no variable. So positive 2 is the only constant in that expression. So expressions are made up of terms separated by addition or subtraction symbols. Most have coefficients and or constants within them as well. So let's go to this problem. 7x plus 5 minus 3y plus 4ab plus m. And I would like you in your notes to go ahead and answer the questions that are there. As usual, pause the video and then play it when you think you have all the correct answers. All right, so the first thing we're supposed to answer is how many terms? There are 5 terms in this expression. Positive 7x, positive 5, negative 3y, positive 4ab, and positive m or positive 1m. So there are 5 terms, and I just read off what those terms actually are. And once again, don't forget the signs in front. What are the coefficients? Well, positive 7 is a coefficient, negative 3 is a coefficient, positive 4 is a coefficient. And remember, they're on a variable without a number. There really is a number there. We just don't have to write it. And so positive 1 is also a coefficient. And then we have that positive 5 with no letter next to it. Remember, that's not a coefficient. We call that a constant. All right, let's go to the next problem. Same idea. Actually, I thought we had more of those. I guess we don't. So one thing that we spent quite a bit of time on in the 7th grade is simplifying expressions, or sometimes it's referred to as combining like terms, where we are only gathering like things together. So if you were at Waterford Junior High last year and you had me, one of the things that we talked about is highlighting like terms. So first thing I did was I put a 1 in front of that x, and then we have another 2x, and it is positive. And notice that I always highlight or circle the sign in front so I know whether it's positive or negative. And so altogether, by combining those x's, we have positive 3x's because we have a positive 1x and a positive 2x. Now we have the y's, and typically I just use different shapes for different terms. So notice I'm using rectangles now. I'm even using different colors. So we have a positive 3y and a positive 4y. Well, that makes positive 7y's. That's why I wrote plus 7y. And then I also have some z's, so I'm going to use triangles, green triangles here. So we have a negative 2z and a positive 7z. That makes positive 5z's. And so that means that that first problem simplifies to 3x plus 7y plus 5z. Let's go down to the next one. We have some x's, some y's in this one. So let's deal with the x's. And just a reminder here, as I just brought up, it is the commutative property that allows us to do what we're doing here. In other words, combining like terms or adding terms out of order. So we've got some x's. A negative 5x, a negative 3x, and a negative 1x. That makes 9 negative x's, so negative 9x. And then we've got some y's, a positive 4y and a positive 6y. That makes plus 10y. So that expression simplifies to negative 10x plus 10y. And when we're writing answers to expression problems, we typically like to write them with the variables in alphabetical order. And notice that I did do that in both of those problems. All right. So it doesn't matter whether the coefficients are integers or if they're decimals or if they're fractions, we still follow the same rules. So for example, number one, we have a positive 3x and a negative 0.8x. We could also think about it this way if we wanted to. But regardless, we have a positive 3x and a negative 0.8x. We have more positive x's than negative x's. In fact, we have 2.2 more positive x's than negative x's. All right, everybody pause the video and quickly try number 2. Okay, so we could leave it like it is, or if we wanted to, we could add the opposite. We have 3.2 positive c's and 5 negative c's. We have more negatives than we have positives. We have 5 negatives, 3.2 positives. So I'm going to make that 5.0 negatives. And then we would have to do some borrowing here. And so clearly we have more negatives than we do positives and 1.8 more. And those are both C, so negative 1.8 C. All right, now with multiple terms. Notice we have some terms with coefficients and then terms with constants. So we would gather our x terms together. We have 2 negative x's and then another 3.9 negative x's. That's 5.9 negative x's. And then we have our coefficients here. We have 9 or 9.0 positive coefficients and then 1.2 negative coefficients. We have more positive coefficients than negative. In fact, we have 7.8 more. So this expression simplifies to negative 5.9x plus 7.8. And I would like you to pause the video and go ahead and quickly do number 4. All right, so we've got 1.2 positive w's and 6 negative w's. We have, or 6.0 negative w's. We have more negative w's than positive w's. In fact, we have 4.8 more negatives. And if you're not sure, 6.0 negative w's 6.0, and 1.2 positive W's, and you can see that we do have 4.8 more. And now we deal with the constants here. So we have 19 positive constants and 2.5 negative constants. We have more positive constants than negative. We have 19.0 positive, 2.5 negative, and that would be 16.5 more positive constants than negative. So that expression simplifies to negative 4.8 W plus 16.5. Continuing on, now fractional coefficients. Well, it does not change what we do. In number 5, we have 1/2 x plus 1/3 x. So we can combine those two together, but we have to make sure that we turn them both into expressions with the same denominator. And that's by multiplying top and bottom by 3 and top and bottom by 2 right there. And so that gives us 5, 6x because they're both positive. All right, and remember, at any point you can pause and go back if I'm going a little too fast. All right, everybody try number 6. All right, so just like the previous one, we'll have to find a common denominator here, which happens to be 14. We have to multiply by 2 over 2 there, so that would be 8 14th C and 7 over 7 there. So that is 7 14th C. We now have common denominator, so we have like terms. And hopefully it's clear to you that that would be 1 14th C. Okay, so this is a 2-day lesson. If you're watching this at home, this probably would be a good point to stop the video for today, go in and get whatever homework you can get done in My Open Math, and then resume the rest of this lesson tomorrow. Okay, so let me go ahead and bring up that answer. And so I'll stop so you can pause it, and then tomorrow you can continue. All right, so continuing on from 7th grade and 6th grade, the distributive property. Remember, when we're using the distributive property, we're multiplying the outside number by everything on the inside, and you've got to make sure you don't forget to multiply everything on the inside. So for example, background knowledge here, that expression 5 times the quantity x plus 3 simplifies to 5x plus 15. Even if you have a fraction on the outside or a decimal, it doesn't change what you do. 1/2 x times x is 1/2 x, and 1/2 times 8 is 4, so we end up with 1/2 x minus 4. And then also, from 7th grade, you would have had problems where the outside number may be a negative number, but that doesn't really change what you do. And by the way, you should be copying down things in your notes right now. You should not just be watching the video, just to remind you. So in this particular problem, we have negative 6 times 5y, which happens to be negative 30y. And then we have a negative 6, and here's where we have to be careful. This is where people tend to make a mistake. That second part is really a negative 6 times a negative 9, which happens to be positive 54. And you can see right there that it will become plus 54. So that would be negative 30y plus 54. And all I'm doing is I'm quickly going through some of the stuff from 7th grade here. In the next problem, we've got an outside number of negative 4. So we're going to multiply negative 4 times 6y. And then negative 4 times a positive 7 right there. So we end up with negative 24y minus 28. Some people will want to write that as negative 24y plus negative 28, which technically is the same, but in My Open Math it's going to mark it wrong because we need to write things as simple as possible, which in this case would be negative 24y minus 28. Continue on. stuff from the 7th grade. And then in the 7th grade, we expanded out. Well, sometimes you've got to use the distributive property and then combine like terms. So we use the distributive property to get that. And then we have some like terms that we can combine together. So this simplifies to net 9x plus 28. Okay? And then maybe a problem like this one where we have to actually use the distributive property twice. So we end up with 3k plus 3m, and then plus 5k plus 10m. But we're not finished because we can combine our k's together right there, and we can combine our m's together right there. So the entire original problem simplifies to 8k plus 13m. That all should seem relatively easy so far. So our focus on practicing is going to be focused around the idea, well, what if you've got negative numbers on the outside? Because that's where people tend to make mistakes. So we're going to do number 7 together, and then I'll have you try number 8. So we're going to, first of all, use the distributive property. So the first part becomes 3k plus 3m. Nobody's going to make a mistake there. It's this part where people might make a mistake. So we've got negative 5 times positive k, that is negative 5k. And then we've got negative 5 times negative 2m right there. That's where you're likely to make a mistake if you're not careful. And negative times a negative is a positive, so that would make positive or plus 10m. And then from there, combine like terms. We've got more negative k's than positive. And then as far as the m's go, both are positive, so that would be plus 13m. So negative 2k plus 13m. So notice, negative number on the outside, negative number on the outside, negative number on the outside. We've got to pay a little more attention to what we're doing here. So I would like everybody to pause the video, try number 8, then play to see if you got the problem correct. So go ahead and do that, please. Okay, so let's take a look at number 8. So the only thing that we are multiplying the x plus 1 by is the negative 3, not the 5x. It's the part that's right next to it. So as far as the 5x goes, we're going to start like that, and then we start multiplying things together. So negative 3 times x is negative 3x, and then negative 3 times positive 1, that's minus 3. And then we can combine like terms here. So a positive 5x and a negative 3x makes positive 2x, and that's 2x minus 3. All right, go ahead and pause the video. And, anytime you miss a problem, you really should erase it in your notes and fix it to what it should look like. And that goes for any problem, okay? So let's pause the video, try number 9, then press play and see if you got the problem right. All right, let's take a look at number 9. So we're not going to multiply the a by what's inside the parentheses of 4 plus a, only the negative 2. So a, and then now we're going to multiply the negative 2 times the positive 4, that's negative 8. And then we're going to multiply the negative 2 times the positive a. Negative 2 times positive a is negative 2a. And then we're not going to multiply the negative 2 times the minus 1 at the end, because the minus 1 at the end is not within the parentheses. So we just sort of bring down that minus 1. And then from there, we are going to combine like terms. So we have a positive 1a and a negative 2a. That's negative 1a. I like to write it as negative a. And then our constants, we've got a negative 8 and a negative 1. That is minus 9. So number 9 simplifies to negative a minus 9. All right, go ahead and pause the video, fix any mistakes you may have had there. Try number 10, then press play. Number 10. So the only thing that we're going to multiply the w minus 3 by is just the negative 6. Not the 3w, not the minus 4 right after that, only the negative 6. So we can kind of bring down the 3w minus 4, and then when we multiply the negative 6 times the w, that's where that comes from. And then negative 6 times negative 3, that's where the plus 18 comes from. From there, we can combine like terms. Positive 3w and negative 6w make negative 3w. And then as far as the constants go, a negative 4 and a positive 18, that makes plus 14. So negative 3w plus 14. So we've got another block of problems continuing on here, which are actually easier than these, but if I don't talk about them, there will be some mistakes. And that would be, what if you only have a negative symbol on the outside of a set of parentheses? Well, you could think of that as a negative 1 on the outside of the parentheses, but I tend to not think of it that way. So you can start with the 6t. We're not going to multiply the 6t by what's inside the parentheses, only the negative symbol. So here we have a negative symbol times positive 2t. So a negative times a positive is a negative. In other words, a negative times a positive 2t is negative 2t. Then we now have the negative symbol times the negative 5. So we have a negative times a negative 5. It should be clear to you that that is plus 5. As far as the plus 4, that's not in the parentheses, so you can kind of bring it straight down like we did with the 6t. And then, of course, like in all the other problems, we're combining like terms. So we have positive 4t plus 9. All right, so I would like all of you to pause the video and go ahead and try both number 12 and then number 13, and then you can play it and check to see whether you are right or wrong. Okay, so let's take a look at number 12 and number 13. Number 12, we start with 5x, and then we're only multiplying the negative by the x and then the negative by the positive 1. So that gives us 5x minus 1, once again, because we have a negative times a positive x, that gives us negative x, and a negative times a positive 1, that's what gives us the minus 1 right there. And then combine like terms where we can. We have a positive 5x and a negative 1x, that makes positive 4x, and nothing to combine with the constant of negative 1, so that simplifies to 4x minus 1. Number 13, we don't multiply the a by the 4 plus a, only the negative symbol. So when we do that, we end up with a minus 4 minus a minus 1. Well, when we combine like terms here, the negative a and the positive 1a, that makes 0a. So we don't write 0a, we just don't even write it at all. So all we have really are the two constants to combine together. So in simplest form, this expression simplifies to negative 5. Remember, not 0a minus 5, because if you're saying you have 0 a's, that means you don't have any a's. So we don't even write that part down. Okay, so the last idea for today, which is also from 7th grade, is this type of problem right here, which typically some students struggled a bit with in the 7th grade because of their refusal to check all of the answers. So what you're doing is you're given this expression right here, and then you're asked to select all the ones that are equivalent to it. Well, one way to think about equivalent expressions is if you simplify the original one, So let's do that. So we have negative 6x plus 12, and then plus 5x. And then we can combine like terms right there. So we have negative x, or negative 1x plus 12. So any other expression from these 5 right here that also simplify to negative x plus 12, they are also equivalent to that original one. So that's what I was saying just a second ago. You actually have to check some of them. Well, first of all, you can eliminate 1. Clearly, b is not equivalent to negative x plus 12. However, this one is. And then at that point, we've got to check a and c and e just to see if they are. So let's do that. So here we have negative 6x minus 18 plus 5x. I think we can already see that even though we get negative x, didn't mean to write negative 1x, we've got that negative 18 there. So this one is not. Then, part C. So we've got negative 3x plus 6. And then we've got positive times negative 3x. That's negative 3x. And then positive times positive 6. That's plus 6. And then plus 5x. Now, we combine like terms. So we have negative 6x plus 5x. That's negative x. And then our constants, we have plus 12. So this one is. So I know I've got a big mess here, but right now C and D definitely are. We need to check E. So let's check E. We've got negative 7x plus 6x plus 12, and that is going to be negative x plus 12. So it looks like C and D and E, they all simplify to negative x plus 12, so they have to be equivalent to that. And sure enough, those are the ones that are. So this kind of problem takes a little bit of work, but you just have to check all of the possible answers to see which ones are. Okay? So we're going to end this lesson with this problem. It's the same idea, but we notice that we do have a decimal on the outside of the second set of parentheses. So at this point, you really should pause the video and then check the answer whenever you have it finished by pressing play. Okay, so the ones that are A, and the reason is because when you simplify this, you end up with, didn't mean to write that, 13.6x minus 8 when you do all the simplifying there. Clearly B is not because of the negative 4.6. C ends up being equivalent to it, and also E. So when you're doing these kind of problems, sometimes there's only one, sometimes there's two, sometimes there's three, like in 14 and 15, sometimes there's 4, and sometimes all of them are. So when you're doing this kind of problem in the assignment, please do not just guess until you get it right, because it probably will take you a long time if you try that. All right, so that is it for this lesson. Remember, this was a 2-day lesson, which means 2 days to get the assignment done. We end every day with what we did for the day, and we reviewed today expressions and properties. That was the main idea. All right, we are finished for this 2-day lesson.